Thank you very much. It's a great pleasure to be here. And just so you know, there are going to be some slides here somewhere.
Hold on.
Whoops. But also there are copies of my speech that if anybody wants to look over it, they're very welcome to. Now, the question I was asked... Yeah, thank you very much. The question I was asked was, energy crisis. What's to be done? And quite frankly, I don't think there is a crisis. There are enough power stations here in Ireland to keep the lights on. But the problem is that you want to decarbonise. You want 40% of your electricity to be generated from renewable sources. Great aspiration. But the problem is that you've got amongst the highest prices in Europe. And therefore, I would say it's incumbent on society as a whole to make sure that the route you choose to decarbonise is as low cost as possible. If your people of Ireland are already paying over the odds, you can't layer more penalties on them. So you've got to do it at lowest cost. And my own view is that building yet more wind turbines is not the right approach. There are cheaper ways of boiling a green kettle. In the next few minutes, what I hope to show you is that there is an alternative, and it's cheaper, lower cost, and less risky. Has this gone the right way? Yes, it has. So why wind power at all? And I think that's a bit of history. In 2007, Ireland took the decision to really go primarily for wind as its form of renewable energy. That made great sense. To be honest, it was the only viable option at the time to do a large amount of renewable power, and people like Eddie were around that could surely do something like that. And by the end of 2013, beginning of 2014, you'd already got to 20.9%. Now, this required 200 wind farms. So what does the next bit going to need? Well, if you want to go to 40% and it's primarily wind, you're going to have to double the number of wind farms. 20 times 2 is 40. That's about 2,000 more wind turbines. You're going to need another 700 kilometres of overhead lines. That's going to cost about 3.9 billion euros. That's over 2,000 euros per household. And you're going to need hundreds of more pylons around. And the trouble with these things, they're not tiny. You can't hide them by a hedgerow. And you can see there it is compared to Liberty Hall and to the pylons. They are very, very large. And that will have an impact on the rural economy of Ireland and the people who work in the rural economy of Ireland. And in particular, your bloodstock industry is getting a bit nervous about this. And Anne-Marie, who looks after the legendary Coolmar stud, has said that it's obvious to anyone working with racehorses that industrial-scale wind farms and the associated pylons is simply not compatible with rearing, breeding and racing racehorses. So, is there another way? Well, the thing is, or the problem with wind power, and I have to say for solar as well, is that they are variable. And the problem with electricity, and I've spent my life in the electricity industry and I know, is that it's difficult because you have to balance supply and demand on a minute or on a second by second basis. So when you increase demand, EirGrid has to increase the amount of generation. And when demand falls, you reduce the amount of generation. Now, wind is a variable generation, so as wind goes up and wind goes down, EirGrid has to tell the power stations to increase or decrease. And that causes problems. But when wind is only a small contributor, 20%, I think, Eddie, you were alluding to 25%, when it's only a small contributor, the variations in the wind are smaller than the variations in demand. So changes in the wind don't have a drastic impact on the way that EirGrid runs its power stations. But if you want to double the amount of wind power, then it will be the variations in the wind that will determine how EirGrid varies the output of the power stations most of the time. So not only, if you want to accommodate 40% wind, will you need to build transmission lines costing 3.9 billion euros, you're also going to need extra power stations there for when the wind does not blow. You want to keep the lights on. But also, when you change the way that these power stations operate, the gas-fired power stations, then you change their operating efficiency. And you lose efficiency. It's like when you're driving a car. If you're driving a car through Dublin and it's stop, start, stop, start, your fuel consumption is very high. But when you're bombing along the motorway, or let's say just doing 60 or 70 kilometres an hour, your fuel consumption is very low. So it's exactly the same with the impact of wind on the transmission system, that EirGrid has to change the way that the power stations operate. And that costs money. You can't ignore it. And the Irish Institute, or Irish Academy of Engineers, tried to work out what these additional costs would be. And Eddie's wind power is, let's say, 7 cents a kilowatt hour. The additional system costs another 3 cents a kilowatt hour. So that's a 40% increase that you just don't see normally. That is the hidden cost of having variable forms of generation on the system. And the industry up to now has kept that really quite secret, to be honest. It's never been published. And these numbers have recently been confirmed by the all-island committees that are linked to your single electricity market. So, whoops, what happened? So my point is that wind power is neither zero carbon nor is it free. When these power stations don't operate at their best efficiency, you emit more carbon dioxide, so your emissions go up. And I just happen to think that there's an alternative, which is repowering of your Money Point power station. Now, Money Point is a big power station down in the southwest of Ireland. I know it quite well because it was commissioned when I started my career. That's how old I am. And it's ideally situated. And the option is that you could burn sustainable biomass at Money Point. Now, what is sustainable biomass? Well, what happened was, in the middle of this last decade, when Ireland was just about to start to think about how are we going to meet our renewables target, a number of utilities around Europe wanted to go green, wanted to go carbon neutral. And they found that they could burn biomass with their coal-fired power stations in it alongside the coal. And the more biomass that they burnt, the more credits they would get for being green. And they started to have technical problems with this, with burning biomass in a coal-fired power station, but they overcame those problems. And also they worked out a way of checking that this biomass that you were growing really was, or burning, really was sustainable. They worked out a way of auditing that you only took the tops of trees, you took the twigs, you took the branches, the stuff that wasn't of use for anything else, the stuff that you'd normally leave on the forest floor when you harvest the trees, that you could make into pellets. And they worked out how to audit it, how to verify it, and the whole industry started to work. It started to be created. It didn't exist in 2007, but it exists now. And in Yorkshire, in the UK, a big change happened, in so much that one of the power stations there, Drax, decided to convert to sustainable biomass. And all of a sudden, this became possible to burn this biomass in a coal-fired power station, and it is green because it is zero carbon emissions. Because if you burn this biomass, or you buy this biomass to be sustainable, you've also got to plant the trees as well. So it's a kind of a circular economy kind of thing. You grow the tree, you burn, or you grow the tops of the trees, you use the other stuff for furniture and the like, you burn it, you emit carbon dioxide, and then the new trees that you've planted take the CO2 out of the atmosphere. So it's circular. It doesn't increase the amount of carbon dioxide in the atmosphere. So we found out that you could do that. At Drax, they built the whole power station, or they made the whole changes to time and to cost. No reduction in efficiency, no lowering of its output. They found that when you imported this biomass from America, even after you'd taken into account the cost of processing the stuff, putting it onto boats, shipping it across the Atlantic, shipping it up the English Channel, up the North Sea to Yorkshire, putting it onto trains, taking it all the way into Drax, your emissions of carbon dioxide were still 85% lower than what they would have been with coal. So it really does reduce carbon dioxide emissions. So and they found out the biomass market in Europe became larger and larger and larger. People became more confident to grow trees for this market, and all of a sudden you could get long-term fixed price contracts which will give you the price stability that you're looking for. So I really think that's something that we need to look at. Now, Moneypoint, it's even in a better position. So whereas you'd have certain costs at doing it up at Drax, you can work out quite easily what the cost would be for doing it at Moneypoint. In fact, the conversion cost would be about 380 million euros. That's a tenth of the changes that you'd have, the cost of the changes you'd have to do to the transmission system to absorb all that extra wind. So if you also work out what the cost of buying this biomass would be, and you compare it to what the full cost of the wind is when you allow for the fact that you've got these system costs, then it's lower. In other words, a Moneypoint conversion would be cheaper than building yet more wind turbines. So it's easier because you re-engineer an existing power station at a cost of €380 million. It requires no change to the transmission system. You don't need any more pylons around the place. No changes to the transmission. There's no threat to the transmission system's stability, and you don't need any more backup. And when you do the sums about how much can I buy this biomass for under long-term contracts, how much carbon am I stopping going up into the air, and compare that with the carbon that you stop by going up into the air if you build a wind farm, you find the cost of carbon abatement at Moneypoint are about 60 euros a tonne of carbon dioxide, whereas the cost of carbon abatement from more wind farms is much closer to 135 euros a tonne. So to my mind, it's a no-brainer. It's cheaper. You can do it. There's no risk to your electricity system because you're running exactly the same systems as you're doing before. And more importantly, there is no risk at all to your rural economy. So your bloodstock industry would be absolutely fine were you to do this rather than put wind turbines and pylons near them. So have you got an energy crisis? I don't think so. But possibly you're going in the wrong direction. You've got double the amount of capacity you need at the moment, but you want to meet this 40% renewables target. And my argument is, and I hope I've convinced you today, that Moneypoint can be converted quite easily. You don't have to turn it off all the year. You can just do the conversions in the summertime. So that is your cheapest, least carbon way of doing it. After all, Moneypoint is your largest single emitter of greenhouse gas in this country. How can you possibly go on building wind farms yet at the same time you're chucking out all the CO2 from this largest polluter down in the southwest? So I don't think that you're facing a crisis. I think you need time to rethink, think about what you're doing again. And Moneypoint gives you the option of kind of delaying. You can convert Moneypoint, delay, and then by then the kind of storage options that Eddie's looking for may well have come into more than just mass production, but their costs would have come down by then. So I recommend to you, now is the time, not for a crisis, but time to have a really good rethink and convert Moneypoint. Thank you.